Hello and welcome to Jonah Perkins and Kyle Shepard's presentation on dark energy and dark matter. In the 1990s, scientists believed that due to the increase in the universe's gravitational force, its acceleration outward would slow down and eventually reverse. This was disproven in 1998 when the Hubble Space Telescope observed a galaxy from long ago that proved the universe was expanding slower back then. None of these scientists understood why the universe's expansion was accelerating, but they named the unknown reason dark energy. Today, scientists still don't understand dark energy, but they have produced four main theories that might explain it. Theory 1. The first theory is that dark energy is a property of space. When Albert Einstein discovered that empty space wasn't nothing, he also discovered that empty space can possess its own energy. If this energy was a property of space, it would not be diluted as space expanded. When the universe expands, more of this energy would come into existence, causing the universe to expand faster and faster. Theory 2. The second theory is based off the quantum theory of matter. This theory describes how empty space is actually full of temporary particles that continuously form and then disappear. However, when physicists tried to calculate how much energy empty space would hold, they got a number that was approximately 10 to the 120th power times too big. Theory 3. The third theory is that dark energy is a completely new kind of dynamic energy. This new kind of energy would be almost completely opposite from normal energy. Scientists call this theory the quintessence, but even if this theory is correct, there are still many unanswered questions about this new kind of energy. Theory 4. For the final theory to be true, Einstein's theory of gravity would have to be completely false. This would not only change the way we understand the expansion of the universe, but the way normal energy behaved in galaxies we have already observed. While the new gravitational theory could solve the unknown mystery of dark energy, we have no idea where to start for this new theory. There have been a couple attempts to create a new theory, but none have been successful yet.
For the most part, dark matter is a mystery. We believe that it makes up about 27% of the universe, but it doesn't emit light, so we can't observe it with any of our current tools. So what is it exactly? Well, it is much easier to talk about what it isn't. We are fairly certain that it isn't made up of normal atoms, that the planets, stars, and everything else that we can see around us is made up of, because we can't see dark matter at all. I will talk a little bit about theories behind dark matter's composition later. It also isn't made up of dark clouds of normal matter, because we would be able to detect the absorption of radiation passing through them. Dark matter isn't the same as antimatter because we do not see the unique gamma rays that are produced when antimatter annihilates with matter. We also know that the effects dark matter has can't be explained through black holes based on how many gravitational lenses we see. To briefly explain this, high concentrations of matter bend light passing near them from the objects further away, but we don't see enough lensing events to suggest that they would make up the required 25% dark matter contribution. And finally, we know that dark matter isn't dark energy, which by itself makes up approximately 68% of the universe. You might be asking something along the lines of, how do we know it's really there if we can't see it? One thing we do know is that dark matter interacts with regular matter through gravity. If we measure the gravitational effects it has on large structures in the universe, such as galaxies and galaxy clusters, we can determine how much is there. Astronomers have used this to create maps of the distribution of dark matter in the universe, even though it is invisible. There are many different theories on the composition of dark matter, so I will only talk about the most popular ones. Some people believe that dark matter actually is made up of what we consider regular matter, that is tied in brown dwarfs, substellar objects that have a mass between the largest gas giants and the smallest stars, or in MACHOs, which stands for Massive Compact Halo Objects. Other physicists believe that dark matter consists of an unidentified subatomic particle. One theory is WIMPs, which stands for Weakly Interacting Massive Particles, that are believed to have been produced in the early universe, or another particle with the same properties as them. However, no evidence has proved this to be the case. Other people believe that the axiom is a stronger candidate, and it also is thought to solve some other physics issues like the strong CP problem, but I won't dive into that. These are the sources that we used. Thank you for watching our presentation. We hope you enjoyed it.